All right, so today we're going to be talking about unit conversion and metric units. Again, I have these as Cornell style, so I have your questions here on the left and the main notes over here on the right. First question, what are metric units and what are some examples? Well, metric units are internationally accepted units to quantify or measure everything from distance to mass to time and energy. It is easy to convert between different magnitudes, and magnitudes just means sizes, of the same type of metric unit. So a few examples of metric base units are meters, which we use to measure distance, grams for mass, joules or joules for energy, liters for volume, newtons for force, and bytes for data or data. There's plenty more examples of metric base units, so I would like you in your notes to go ahead and take the time to figure out at least 2 more metric units that we use. Make sure they are base units. So like this one right here, meters, that's a unit of measurement. It's about 3 feet or so. And then a kilometer is a little more than half a mile. But a kilometer or a kilometer is just a different way of measuring meters. So a kilometer is not a metric base unit, but it is a metric unit. So think of things that we could put words like kilo or deca or deci or centi or milli or giga in front of, and I want the word that goes behind the kilo or the giga or the centi or the milli. Okay, so not kilometers, but meters. Not kilograms, but grams. Not milliliters, but liters. Okay, so come up with 2 more things we could put there as more examples of metric base units. So how can we modify the name of a metric unit to express its magnitude? All metric units can be modified with a prefix to let us know that we are dealing with a much smaller or a much larger unit. And just a quick ELA reminder, a prefix is a word or letter that attaches to the front of another word to change its meaning. So if I have a word like believable, and I want to turn it into unbelievable, I would add the prefix of un, which means not. So believable is the word, un is the prefix, and together they make unbelievable. Now in metric, we have some common metric prefixes. Kilo or kilo, 1,000 or 10 to the 3, and we write it as a K. So if you have 1,000 meters, you have 1 kilometer or kilometer. Hecto is another prefix. It means 100 or 10 to the 2nd power, and we write it with just a lowercase h. Deca means 10 or 10 to the 1st power, and it can be represented by either a DA, a DK, or capital D. It's written a few different ways, but DA is the one that I see most often. So if I have a decaliter or 10 liters, I would write it DAL, decaliter. Then if we go into smaller sizes, a deci is 1/10 or 10 to the -1, and we represent that with just a lowercase d. And then we have centi, which is 1/100 or 1/100th, 10 to the -2. We represent that with c. So a centimeter is 1/100th of a meter. A millimeter or a milli is 1/1000th of the base unit. 10 to the -3, we represent that with m. There are plenty more prefixes that we use in metric. Can you think of any more? Think of the size of a computer hard drive. How do we measure that? I already mentioned that bytes is a metric unit. When we're measuring like hard drive space, we're normally talking about bytes, but we're normally probably not talking about regular bytes. We put an extra prefix in front of there. What's that prefix? Do you know any prefixes for even smaller measurements, so even less than 1/1000th. Do you know the prefix for 1/1,000,000th? How would you say that? Do you know the prefix for a million? Kind of try to figure those out. First, try to just think about it, and then if you still can't figure out what it would be, if it just isn't popping into your head, then you can search for it. But I want you to use your own knowledge, your own memories first. All right, so how to convert between magnitudes of metric units? Well, scientific notation can actually help us. Every prefix is a power of 10. Scientific notation uses powers of 10 to make numbers easier to write and eliminate insignificant zeros. How can I use knowledge of powers of 10 and scientific notation to convert meters into kilometers or kilometers? Well, the base unit is 10 to the 0 power. Let me correct that. 10 to the 0 power. If I want to convert 37 meters, 10 to the 0, into kilometers, 10 to the 3rd power, I subtract the exponents and write the new value in scientific notation. So what I did is I took my original power of 0, I subtracted my new power, the power I'm going to, kilometers, subtract 0 minus 3 equals -3, and it gives us a -3 power. So 37 times 10 to the 0. Let me write that over here. So 37 times 10 to the 0 minus 3. So 37 times 10 to the 0 is our meters. Minus 3 is moving to kilometers, which gives us 37 times 10 to the -3 power, which I wrote here in the black pen before. So 3.7 times 10 to the -3, but it's not in scientific notation. So I have to take the decimal from back here, move it forward, and I come out with 3.7 times 10 to the -2 kilometers. But that is not scientific notation yet. Yes, it is, because we just fixed it. Move the decimal to get 3.7, and then adjust the exponent. So that's right up there. Now we finally need to write this in standard form. So we're going to take 3.7 times 10 to the -2, and we're going to take that -2 power, and we're going to move the decimal 2 times to make our answer an even smaller number. So make our answer less than 3 because we have that negative exponent. So move it 2 times, and we come up with 0.037 kilometers. Okay, so let's say all this powers of 10 stuff just doesn't work for you. So you're probably asking me and yourself, are there any shortcuts? Yes, there are shortcuts. There are also what's called mnemonics, or ways to help you remember the prefixes. So we're going to talk about 3 different ways that we can make this a little easier on ourselves. Our first shortcut is the line method. The second shortcut is the stair method. And then there is a mnemonic, or a memory device, that you can use to try to remember what order each of our prefixes are in. So the one that a lot of people use is King Henry died by drinking chocolate milk. But DA for Deca, it doesn't really work with died. So I made this a little better. How about K-pop heroes dance better? Don't confuse mastery. All right, so K for kilo, H for hecto, DA for deca, B represents our base unit, D is for deci, C is for centi, and M is for milli. So that's how you can remember, if you can remember either of these, that will help you remember the order of your prefix letters. All right, so how does the line method work? Well, first we just set up a line, and then we're going to put each of our prefixes up here. Base is just the base unit, It doesn't really have a prefix, so I just wrote base in there. And then remember that those K-pop heroes dance better. Don't confuse mastery. Kilo, hecto, deca, base, deci, centi, and milli. And I also put the letters K, H, DA, blank, D, C, M. And I also have our scientific notation or our powers of 10 down here. So 10 to the third, 10 to the second, 10 to the first, 10 to the nothing, 10 to the negative 1, 10 to the negative 2, and 10 to the negative 3. Okay, so the first thing we're going to do when using the line method is first we need to identify the given measurement. If there's no decimal point in the number, then you just write one at the end. So I'm going to write over here, identify. Step 2, locate. I'm going to put that over here. Locate the position of the given unit compared to the unit you need to convert to. So figure out where we start and then figure out where we're going. Step 3 is to count. We're going to count the number of spaces between both units, starting with our given measurement. So figure out where we are, where we need to be, and how we get there. So first we plan it out. Last step is we move. We move the decimal point from the starting point on the line to the ending point. Figure out where am I now? Where do I want to be? How do I get there? And then make it happen. So those are your 4 steps. And I'm going to put that over here, make it make a little more sense and be more visible. So let's put these all together now. So if I want to use the line method to find out how many kilometers are there in 25 decimeters. This is a lowercase d all by itself, so that means it is decimeters. So step 1 is to identify the given measurement. My given measurement is what? Right here, 25 dm. And if there's no decimal point, go ahead and put one on the end. So I'm going to put a 25 point. So the next step is to locate that on the line chart. So I'm just going to real quick draw a little line chart. I have km, hm, dam, b, or just m, dm. Okay, so I'm just going to put those in there. I don't need everything because this is all I am dealing with. So I'm starting out here. And then step 3 is to figure out how to get there. So I need to figure out on step 2 where I'm going. So I'm trying to go to there. So I need to figure out how far apart they are. There are 1, 2, 3, 4 spaces. Okay, so 25 dm, we're starting here, we're moving to there, which means there's 1, 2, 3, 4 spaces. I have to hit 1, 2, 3, 4 dashes to get there. So if there's 4 spaces in between, I'm going to go ahead and start moving my decimal place now. 25 point, and I'm going to go 1, 2, 3, 4, because I had to move that direction. So I'm going to move the decimal that direction. I'm going to plug in my zeros, and so my answer is 0.0025 km. So 25 decimeters, those are really tiny numbers. If I wanted to know how much 25 little things are compared to kilometers, kilometers again are about half a mile. That is 4 city blocks if you're in Phoenix, probably about the same in Tucson. But half a mile is not small. It's definitely bigger than your house. So 25 little things, of course it's going to be a small little decimal like this. So make sure that your answer is reasonable when you get it. If you came up where you went the other direction and you said that there are 25,000 or something kilometers in 25 decimeters, then you know that you got it wrong, because you're saying there's 25 huge things in 25 of these little tiny things. All right? So just pay attention to your answer, and that will help you know that you got it right. All right, so next question. How does the stair method work? So we have some stairs right here, and there is a lot going on, I know that. But we start with our kilo. The largest one is at the top, 1,000. Hecto, 100. Deca, 10. Base. Deci, 0.1 or 1/10. Centi, 1/100th. Milli, 1/1000th. As we're moving to the right, or we're moving down the stairs, we're actually multiplying by 10. That looks confusing, doesn't it? Because we're going 1,000 down to 100. Why are we multiplying? So what's happening is if I have 1 kilometer and I want to figure out how many hectometers or hectometers I have, remember, kilometers are 10 times bigger than these guys. So in order to go from the big one and cut it up into smaller pieces, I'm actually making 10 times as many pieces. Let me try to say that again. So if kilo were like a whole giant, I don't know, a whole pie or something, and I wanted to know how many hecto-sized pieces there are in there, it would be divided into 10 pieces. Like that, and like that, we'll say. That's probably not 10. 1, 2, 3, 4, 5, 6, 7. That's 8, 9, 10. So there's like 10 hecto-sized pieces. And if I go smaller, there would be 10 deca-sized pieces in every hecto-sized piece, 10 hecto-sized pieces in every kilo pie. Think on that for a second. Okay. So as we go down the stairs, we're going to do times 10. Our exponents are going to get more and more positive and bigger. We start with the huge unit, and we're going down into smaller units. So you're going to have more of these small units compared to the big one. This big one can be cut into all these little pieces. Okay. Now we're going to think about the other direction. And I am going to give an example, so don't worry too much. So we're going to start with the milli. And so that's a really teeny tiny little size. And if we go just a little step bigger, actually I will grab a ruler real quick. Alright, so from here, there we go, that one's bright enough. From here to here, each of these little tick marks is a millimeter, and this whole big one from 17 to 18 is 1 centimeter. So if I started at, let's say, let's ignore this stuff over here. So we're starting at, this is our 0. If I had 1, 2, 3, 4, if I had 4 millimeters, how many centimeters do I have? Well, I don't have 1 whole centimeter. I have 4/10 of a centimeter. So I took my 4 millimeters, divided that by 10, and it gave me centimeters. So if I start with those 4 millimeters, divide it by 10, I get 0.4 centimeters. If I bring it up to decis, then I would have divided by another 10 would be 0.04. Divide by another 10, 0.004, and so on all the way back up the list. So if you're going from a big unit to a smaller unit, you're going to multiply by 10, or powers of 10. If you're going from a smaller unit up to a bigger unit, you're going to divide. So let's go over our steps. Step 1 is to identify again. So you're going to identify the given measurement if there is no decimal point, write one at the end. Step 2, mark your starting position on the stairs. Step 3, walk up or down to your ending point. And then step 4, move the decimal. Move the decimal point to the corresponding number of spaces. Okay, so I'm going to make this more visible. Put a little bubble around it. So here's our example using the stair method. All right, so our example is using the stair method. Find the number of milligrams in 1.4 grams. So first I need to identify what we're using. So we're going to identify the given measurement, which is 1.4 grams. And we know that we're trying to go to milligrams. So step 2 is to mark your starting position on the stairs. So I'm just going to move up to the stairs that I already have here, and I'm going to write my 1.4 right there, because that's where I'm starting. The next step is to walk up or down to your ending point. I'm going from grams to milligrams. So example 3, end. So I'm going to go down 1, 2, 3 times. So I'm going to say marked on stairs, move down 3 times. So I have my 1.4, and I'm going to move my decimal 3 times. And it's telling me that as I go, I'm multiplying by 10, multiplying by 10, multiplying by 10. That means as I move my decimal, I'm going to move my decimal to the right so that my answer gets bigger because I'm multiplying by 10. So 1.4 times 10 would give me 14. A second time, a third time, right there. So my answer would be 1,400 milligrams. So 1.4 grams equals 1,400 milligrams. These are the same exact measurements. If I'm moving from grams to milligrams, I multiply by 1,000. If I'm moving from, 1, 2, 3. If I'm moving from milligrams to grams, then I would divide by 1,000 instead. Okay, so we're going to do an example using all 3 methods of conversion. So we're going to use dimensional analysis, where we use ratios. We're going to use the line method, and we're going to use the step method, or the stair method. And our goal is to convert 31 meters per second into centimeters per second. So you may remember this 31 meters per second number from yesterday, where we came up with the 70 miles per hour converted into meters per second. We're going to take it one step further and take it down to centimeters per second. So the first step, dimensional analysis by using ratios. We're going to start with 31 meters per 1 second. And then we're going to set up our, dimensional analysis table, which you guys are probably going to prefer to use parentheses because you are 8th grade. You are not in high school or college yet. So we're going to do it old school. We're going to do it parentheses times our first ratio. So we're trying to convert meters into centimeters. So what is our conversion factor? How many centimeters equals 1 meter? Well, there's 100. Centimeters equals 1 meter. So our ratios could be either 100 cm per 1 m or 1 meter per 100 cm. So 100 centimeters per 1 meter or 1 meter per 100 centimeters. Which one should I use? What unit am I trying to cancel out? Well, I'm trying to make meters into centimeters. So I want to get rid of these meters. So I need to put something here that can get rid of it, which means I need to put my meters on the bottom, which means I have to use this ratio right here. Okay, so now I can cancel out meters and meters. So I have 31 with no units times 100 centimeters over 1 second times 1 no unit would give me centimeters per second. So I have not done any math yet, but I already know I'm going to get the correct answer as long as I multiply correctly. And so if I were showing my work on a test and I showed all these steps, I would get most of my points even if I do something really wrong and get the wrong answer. But I set it up correctly, and that's the most important part, to be honest. So 31 times 100. Luckily, there's just zeros. I can do 31, and I have 2 zeros. I love multiplying by powers of 10. It's so easy. So I have 3,100 meters over 1 second, which is just 3,100 meters per second. Or centimeters per second. Guys, you didn't catch me on that. Okay, some of you probably did. But I didn't hear you. There we go, centimeters per second. Now we're going to try this using the line method. So I'm going to draw myself a little line. And we have meters to centimeters. I know that meters is here. And then one less than that is decameters. Or decimeters, I should say. And then next is centimeters. So that one's pretty easy. I'm going to start at 31 meters. I'm only paying attention to the meters right now because the per second doesn't change. So I only need to change my meters. So 31 meters is my start. And I'm going to go 2 decimals this way, 2 places that direction. So I'm going to have 31 with a point at the end. And I'm going to move 1, 2 spaces, just like that. And I'm done with the line method. Line method, I personally feel, is the easiest shortcut. But that's just the way that I work. That's just the way that my mind is able to comprehend things. But a lot of people are a lot more visual, and they need a lot more ways to represent it, and for some people the stair or the step method works even better. But for me, the line method and the dimensional analysis methods, these are the ones that work best for me. But we're going to do the stair method because I know some of you are going to really like it and it's going to be the best way for you. So I'm going to do my stairs. I'm not going to do the whole entire stair step because I'm not about that life today. So we're going to start with meters, and then we'll have our decimeters. And then we're going to go down to our centimeters. And remember, we're starting with 31, and we're going down the stairs. Down the stairs 2 times. 2 times downstairs is 10 times 10 equals 100. So we're going to go times 10 times 10. 31 times 100 equals 31 with 2 zeros on the end, centimeters per second. And then all I need you to do is write your summary. Write your own summary of the notes right here. This is worth 2 more points on your notes to bring it up to a total of 10 points. Getting the main notes, getting all of my examples written in is worth up to 6 points. Having your questions is 2 more points. And getting the summary is 2 more. So if you only took this portion of the notes, but you didn't include my examples, you're probably getting a 4 or a 5. You add the questions, that brings it up to a 6, which is a D. And if you add the summary, but you still didn't fill in the examples, you might get a B at best. But if you do all my examples and you get your questions and your notes and your summary, it's a super easy A, guys. All right, I will see you in Zoom.